So now you can see submerged backfill. So I will tell you the meaning of each and every word. The backfill is completely submerged. The meaning of this word is, I have a retaining wall, because when I want to calculate earth pressure, I need to draw a retaining structure. So because the earth pressure is the pressure exerted by backfill against the retaining structure, that's why it is a common diagram figure. We need to draw height of the wall H. But remember, we are using Rankine's theory C0. We have phi, we have gamma, and this time actually gamma saturated. Someone can ask me, sir, why you are writing gamma saturated? So because the reason is very simple. I have water table at ground level. This is the symbol of groundwater table. So water table is at ground level. Now it is gamma saturated. Someone can ask me, sir, tell me any formula G plus E into gamma W by 1 plus E. E is wide ratio. GS, specific gravity of solids. Now, actually, we need to calculate. Firstly, we will discuss active earth pressure. So now tell me how to calculate active earth pressure. So I repeatedly telling K is sigma H by dash by sigma V dash. I want active, sigma H dash is equal to K into sigma V dash. Now I want active PA. Now Ka into sigma dash. Ka into, what is sigma dash? Sigma minus U. Total stress minus pore water pressure. Here I have pore water pressure. Here I am having, but in the previous case, when you assume soil backfill is dry, the pore water pressure is 0. But here I cannot hide it. I should mention pore water pressure here, because water table is at ground level. Water table is at ground level. So without further delay, let us discuss now. So what is sigma now? Can anyone tell me how to calculate sigma? Gamma sat into H. Gamma sat into H. Now how to calculate U, pore water pressure? Can anyone tell me? So I will tell you, pore water pressure U is gamma of water into H. Now, can anyone tell me how to calculate sigma dash now? Which is equal to sigma minus U. So can anyone tell me now what I am getting at the end? I will choose another color. Give me 1 second. What is the diagram? It is 0 here. Can anyone tell me? Right from fundamentals, I am telling what is sigma dash. Sigma dash is equal to sigma minus. This is effective stress. Sigma dash means effective stress. So now you see, this is effective stress. I should mention. You might be studied in geotechnical. So now this will be gamma sat minus gamma W into H. So can anyone tell me what is gamma sat minus gamma W? Gamma submerged. So let me tell you once again, gamma sat minus gamma W is gamma submerged. So this is about vertical stress. So this is about your background. This is about your background. I'm telling vertical stress, but this is not the moment we are discussing about vertical stress. We need to discuss about horizontal stress, which is equal to PA, Ka into sigma V dash. So now I want active force. How to calculate now? Because here the space is limited. I will go like this. So here you see, I will show you. So now let us proceed now. So can anyone help me now? How to calculate active earth pressure now? Take these guidelines. So now you can please tell me now what is the active earth pressure now? Ka into sigma dash. Now this will be Ka into gamma dash H. So this is the pressure from the soil side. This is the pressure from the soil side. So this is the ultimate answer is, you can see this is the height of the wall. So now please tell me now how to calculate force. So how to calculate force? I know area of the pressure diagram. But remember one point, please all of you listen carefully. Whenever water table is there, so water pressure is also acting. You studied in your fluid mechanics. So whenever water table is there, so now you need to add water pressure right from top to bottom. We need to add, please all of you listen carefully. 0 here it is, what is the water pressure? Can anyone tell me? What is the water pressure? I am not asking about earth pressure. Water pressure means gamma of water into height of the water. What is the height of the water here? Here see, water table is at ground level, that is at the surface of the backfill. So that undoubtedly, invariably, I can say that here the head of the water is H. So let me tell you once again, we need to add hydrostatic pressure separately, apart from earth pressure. Then you can call it as lateral earth pressure. So that's why whenever you are calculating lateral earth pressure, especially either it is active or passive or at rest, okay, so whenever you are calculating earth pressure for groundwater table case, when submerged backfill, see this entire backfill is submerged. So whenever you found this case, you please, all of you take care, you must show submerged. What is gamma dash? Gamma dash means, can anyone tell me? Gamma dash means gamma sat minus gamma W. So this is gamma dash means gamma submerged, gamma prime. We are supposed to speak like that. Gamma prime is equal to, which is also designated with gamma submerged. So really see, the original stress, the original ground condition is submerged. That is replicated in effective stress. See, original ground condition is, you can see in effective stress, not in total stress. If you observe total stress, you may be mistaken. See, total stress is saturated. Here the ground is not just saturated, it is submerged. Strictly speaking, it is submerged. That's why you can see in effective stress gamma prime. So always believe effective stress. So write always, whenever water table is at ground level, you can show the diagram gamma prime. In diagram, you can show the pressure distribution gamma prime. But now I decided I want to calculate active. That's why I'm multiplying with Ka. So Ka into gamma dash H. Now this is about earth pressure, lateral earth. And apart from that, you need to add exclusively hydrostatic pressure. No need to multiply with Ka because it is meaningless actually. Why I have to write Ka? Ka is earth pressure coefficient. It is not water pressure coefficient. So it is meaningless. Don't get, many times students are getting confused. They want to multiply with Ka for water pressure. You see, Ka is earth pressure coefficient, active earth pressure coefficient. That's why it is water pressure I am adding exclusive. Right, from top to bottom, I am adding exclusive. Sometimes people asking important questions, sir. Okay, every time you are drawing triangle. My first class, I told you, in the first class itself, I informed to you students why I am drawing triangle, why I am not drawing rectangle. The reason is very simple, because pressure is 0 here. When depth is increasing, when Z is increasing, you see, when Z is equal to H, I can expect maximum pressure at the base. So that's why it is always linear. So water pressure is also here. You see, if you want to calculate water pressure here, 0 here, gamma of water into height of water, 1, gamma W into 2. For example, if height of the wall is 10, gamma W into 10. So now I am getting a triangle. Why it is triangle? Please all of you understand. In the previous case, you might be seeing why it is rectangle, because it is constant. Q is constant from top to bottom. Then if you want active, multiply with K. If it is earth pressure. Otherwise, if it is water pressure, no need to apply. Now, finally, what I would like to tell you, here you see, I want to calculate total force. Now, how I will calculate now? I have PA1. This is first diagram, and followed by water pressure diagram. This is P2. Now, how to calculate capital P? Can anyone help me now? Or am I calculating already? Now, I can do it. Let me select another paper. So now I am ready to do that. I don't want to create any problem. Now let me start now. Here you see, I want to calculate capital P, which is PA1 plus PA2. Now I know how to calculate PA1. It is Ka gamma dash prime, gamma prime h square by 2 plus this gamma W into h square by 2. This is capital P. Now how to calculate y bar? How to calculate y bar? Y bar is equal to PA1 y1 plus P2 y2 by PA1 plus P2. So now my question to you is, I have one question: what is y1? What is y2? It seems to be y1 is equal to y2. Here it seems to be y1 is equal to y2. The reason is very simple. Both are triangles acting at a height of, can anyone tell me? H by 3. H by 3. See here you see, I will tell you, I have picked up the second next case. In this case, I realized I am discussing about submerged backfill. Whenever submerged backfill is there, so you can see here, this is the answer you can expect. We can expect Ka gamma dash H, Ka gamma dash H, and don't forget this is gamma dash, Ka gamma dash H. So now you see this is gamma W into H. Okay, so we will continue the lecture. There is no problem with the lecture. Sir will join. Sir is having some personal work. That's why Sir adjusted the class. So once Sir came, you please inform to me. I will stop the class. Okay. So, but I will try to utilize the time, whatever the time we are having. So now let me tell you. So I am teaching you about water pressure as well as depth pressure. Now the combination you can see, it is PA1 plus P. So now the area of the pressure diagram, you know, Ka into gamma dash, don't forget gamma dash, h square by 2 plus gamma W h square by 2. So I don't want to teach you like a kid of base into height of gamma h into h. So that mathematics I already trained you. So now y bar, how to calculate y bar. So this also explained to you. So this is ground is submerged. So now gamma dash, how I got sigma minus u. Gamma set minus gamma W, the common is h, then gamma dash h. But strictly speaking, this is vertical stress, but I want horizontal stress. So don't worry how to calculate horizontal stress. You see, K is equal to sigma h by sigma v, sigma h is equal to K into sigma v. If you want active, multiply with Ka. If you want passive, multiply with Kp. If you want at rest, multiply with K naught. So we had a wonderful discussions. You cannot deny that. You're telling something new. No. We have our own background. We are spending a good amount of time. And I'm very happy. Many of the students are giving 100% good answers. Okay, good answers. Okay, K gamma dash H. But don't forget to add this water pressure, hydrostatic pressure. We need to add separately. We need to add, this is gamma W H square by 2. So now how to calculate y bar? Y bar means many times I'm telling y bar. Y bar means the point of application of resultant from base of the bar. I will write because I prefer to write point of application of resultant from base of the bar. So someone can ask me, sir, why you are calculating y bar? Because you know, if you multiply force with lever arm, you will get moment. That itself gives P into y bar is overturning moment. This is submerged backfill. Now what I have to calculate now? Yes, passive force. So don't expect too much answer from my side now. We have gamma set, we have C0, we have phi, luckily. Now I need to calculate this is the height of the wall. I should not forget this. So now you see what I have to do now. So now you see this is the answer. No explanation, nothing. Like textbook. Kp gamma dash H Are you ready to say this? Gamma W into H. Gamma W into H. Now, my question is, how to calculate force, which is acting at a depth, at a distance y bar from the base. A distance y bar from the base. Now the question is, this is P1, PA1, this is P2. So now how to calculate capital P? Get ready, tell me how to calculate y bar. So P is equal to Kp into gamma dash. See, they are writing like experts, they are not like me. So now you see, gamma W H square by 2. Now what about y bar? This will be P1 plus P2. Now P1 y1 plus P2 y2 by P1 plus P2, which is nothing but P only. Actually, sometimes people writing P1 plus P2. What is P1 plus P2? P only. What about y bar? This will be P1 plus P2. Now P1 y1 plus P2 y2 by P1 plus P2, which is nothing